Okay, I think we're gonna get started, but we can have more people join us if they come. So thank you for everyone for joining us. CCD is really excited to welcome Dr. Brandon Byers to share his insight and work on the circular economy, share some different models and his expertise with it. So I'll let you introduce yourself, Mr. Byers or Dr. Byers.
All right. Yeah. Thank you, Kira. Let me pull up my screen here. All right. Yep. So super excited to be here with everyone and share some of the my past experiences, also as well as give a general introduction to circular economy and what it could look like for construction. Um, yeah. So I will start with a brief background of myself. So I did my bachelor's in civil engineering at Georgia Tech some time ago, and moved up to Washington, D.C. to work for AECOM, which is a big infrastructure consultant for a couple of years, and had some pretty exciting projects on dams and hydraulic infrastructure. Went out to California for my master's in sustainable design and construction with some folks out there. And somewhat recently, at the end of last year, completed my doctorate at ETH Zurich out in Switzerland, which is broadly our lab there was focused on the intersection between digital transformation and circular economy for the construction industry. So I'll kind of dive into some of that work. And then currently came out to Michigan State to join the RISE Lab, which is the Resilient, Intelligent, Sustainable, and Energy Efficient Infrastructure Materials Lab. So we're out here in the civil engineering department, and I'm a research associate to the folks out here. And so some of the work I've done thus far with this group, with this lab, there's a book put out by the PI by Dr. Jin, Industrial Decarbonization, and we have a chapter on circular economy perspectives for decarbonizing the construction industry. So this is in press and forthcoming. And then we have one journal paper out already for the application of circular economy, specifically in post-hazard infrastructure restoration. I mean, hazards are no stranger to the U.S. Unfortunately, we're hearing the news about what's going on in Texas, and beyond just the human impact, there's also a lot of impact on our infrastructure. And so thinking about how we're going to manage these materials and rebuild is also an important question that we can borrow from the lens of circular economy. So for the talk today, I'll intro with this important number, one third. So the built environment in the construction industry at large is responsible for one third, approximately one third of a lot of things, which include the raw resource consumption, the energy demand and energy consumption, and the amount of waste that is produced. And these numbers are a little bit subject to change based off of who's doing the calculus here, but it's important to recognize how impactful this industry of construction, the built environment really is. And a lot of this can be attributed to what's called the linear economy, or a sort of business as usual, where we have these steps when we think about our materials, where we start at the extraction of the raw materials, this processing, refining, manufacturing of products. We're using these materials for a while, and then usually we just put them in a landfill. And so this is what's called a linear economy approach. And so, what is the circular economy? The idea here is that can we keep materials in circulation for longer? Can we maximize the utility of these materials before we put them out in the landfill? So, there are different strategies for this, which I'll dive into, but it's really about maximizing our material resources before we dispose of them. So I'll cover four different sections in this presentation. I'll start with the circular economy models, kind of a little history, how they've evolved through time. And then I'll move to digital circular construction. How do we adopt different technologies to facilitate these approaches? Then these circular construction materials, with a particular focus on concrete in this presentation, at least, how we can rethink these materials and their applicability for circularity. And then lastly, a bit of future thinking. So what could the future of circular construction look like based off different policies and different companies that are being worked on right now? So to begin, different circular economy models. If we trace back the history of humanity, this idea of a pre-industrial traditional circularity is not so far-fetched from us. I'll start there, then I'll look at a couple different main models, and end with the R framework, which is my personal favorite. But so the traditional agrarian circularity model. So, as I was alluding to, if we think about our pre-industrial ancestors as we were roaming the prairies or the savannas, we have to be more resourceful with the resources that we acquired, right? And so there are these pre-industrial practices that are bespoke to different individual communities. And it's about this closed loop or these localized economies before globalized trade, right? And so there's a lot of reusing and composting. And just a few examples that you can look up in history. If we look at the Byzantine Empire, there were studies showing evidence of local glass recycling. So glass used in some jewelry was also found in different applications for vessels, for instance. In Pompeii, the infamous city that was crystallized in time. If we look back here, we can see that there were recycled materials for construction. So there are some piles of waste that were roughly distributed by their material composition, and some of these could be traced into different parts of construction in the buildings that were in different parts of the city. And then Hawaii or other indigenous island populations, they're very much for obvious reasons our circular economy practices here, right? Where there is no trade, we have to be resourceful for what's available in these localized communities. So this is a bit of a backdrop or historical understanding of circularity in for our species, so to speak. One of the post-industrial kind of modern approaches to a circular economy is called Spaceship Earth, which was initially coined by Kenneth Boulding in an essay, The Economics of the Coming Spaceship Earth, and was later popularized by Buckminster Fuller, a inventor, architect extraordinaire, an operating manual for Spaceship Earth a couple years later. So what is the concept behind this model? It's really about Earth conceptualized as a closed system with finite resources. So Earth is more or less this big rock that is hurling through space, and we kind of get infinite energy from the sun. So we're an open system when it comes to the energy, but we're a closed system when it comes to materials. So there's only a finite set of materials on our Earth, on our spaceship. And so we have to learn how to be careful in how we manage these resources. And so this idea of spaceship Earth emerged. And so it's a lend itself to environmental economics, or perhaps you may have heard of donut economics theory and ecological thinking. And this particular quote from Buckminster Fuller is one of my favorites on this idea of ephemeralization, where that technology can enable us to do more and more with less and less until eventually you can do everything with nothing. It's this idea of kind of optimization or maximal use of our resources. Moving on from there, about a decade later, emerged what was called the performance economy, which largely pioneered by Walter Stayhill out in Switzerland and Geneviève Rodet-Molvet. And so what was this model about? It's about the idea of promoting product longevity, reuse, repair, and shifting from ownership to usage. So instead of purchasing a material and being responsible for the material itself, you would you could basically lease the material as a service, so to speak. So you're buying the utility of the material rather than the ownership. Kind of the classic example that comes from this model is a Xerox machine or a copier machine in offices where oftentimes the enterprises themselves wouldn't own these machines, but would actually have a leasing contract with the manufacturer. And so it removes a bit of the liability from the user. And when they become out of date, their manufacturer can bring back these machines and perhaps repair some parts, extract some valuable materials, and replace them. So this is more about the performance of the material rather than the ownership of the material itself. And also was kind of gave way to another popular concept called decoupling, which is the separation of economic growth from resource consumption. After this, the next popular model was cradle to cradle in 1990. So this was put forward in a book written by Michael Braungart, a German chemist, and William McDonough, who was an American architect. And Braungart kind of, from the chemistry side, was interested in this idea for a while. Then McDonough was able to bring some scale or different perspectives. And so this was about products or systems designed from inception to remain perpetually valuable. And they really focus on the separation between biological and technical nutrient loops, kind of as illustrated in this figure here. And so if you think of something like timber construction, wood comes from it is an organic material and can eventually decompose, but a lot of our e-waste, our electronics, are consists of almost primarily technical nutrients. And part of the difficulty of a circular economy these days is that we're really combining these. And so if we're using both, it becomes difficult for a pure recycling approach because we have organic materials mixed in, and it's difficult for a pure biological approach because we have a lot of potentially toxic materials or heavy metals that are looped in there. So they're really pushing the idea of we should design our products, our systems, our buildings with these two cycles in mind of how can we separate and think about the biological cycles and the technical cycles. Beyond this is becomes the Ellen MacArthur Foundation model. So Ellen MacArthur is an extraordinary woman where she set the record for the solo circumnavigation around the world in a sailboat, I believe in the early 2000s. And then about 5 years later, put together this foundation that was interested in pushing the circular economy models. And I think this is probably the most recognizable from a business perspective. And so it talks about these ideas of regenerative design, renewable energy use, and also pushes a lot of different business models. And so you can recognize a bit on the left, it somewhat is draws from the cradle to cradle model where you have the organic side and then the industrial side here. Um, this is also referred to as the butterfly model, is as a common colloquial term for it on account of its symmetry in this nice little figure here. And then bringing it back to my industry of the built environment. So Arup, which is a big consultant for design and construction, teamed up with the Ellen MacArthur Foundation and created the Circular Leaders Group. And they have a lot of resources on designing for circularity and different toolboxes as well. Um, and then bring it to the most recent model, this 10R framework, or sometimes called the R ladder circularity. And so this actually emerged out of academia. So, if it could be a good or a bad thing depending on your perspective. But when we traditionally think of sustainability, it's a lot of, or the three R's are the most common, right? Reduce, reuse, and recycle. This is what we're taught growing up and are the three main R strategies, you could say. But there was a big review paper in 2017 led by Kircher, Reike, and Heckert that were aimed to synthesize different strategies, lending itself to the broader circular economy mission. And then they categorized them hierarchically, more or less based on their level of importance or level of impact here. And so you can think, so refuse is this top strategy. So can we just refuse the new construction or the new product? Are we fine the way we are? So of course, the most sustainable building is one you don't need to build because you already have a structure available. Then we can think, or there's rethinking of the design itself. So it has maybe increased utility or decreased materials, reducing the amount of raw materials or energy required for the system. And then at the product level, we can think of reuse, repair, refurbish, remanufacture, repurpose. Subtle differences between these, but how can we keep the components in use for longer? And then lastly, our recycle and recovery. And so in my opinion, what's important to emphasize here is that recycling is near the bottom. And for a lot of folks, when we think of circular economy, it's almost synonymous with recycling. But recycling is really only one strategy in this framework. And to draw an example for our industry, we have structural steel elements, for instance. If you buy a new element, it's typically over 90% recycled material already, which is very impressive to hit this at industrial scale. The challenge with this is if you think about what's involved for recycling structural steel, you have these collection processes. You've got to heat up the steel super hot, and you have to melt it back down and cast it into a new shape, which is very energy intensive, which also becomes very cost intensive. And so there are various researchers, both in the US and abroad, that are looking higher up this hierarchy at reusing structural steel. And so this comes after a deconstruction, and then there has to be some testing of these materials. But can we start to standardize this approach to reusing instead of recycling some of the materials that we have? Yeah, and so for product design, management strategy, and research frameworks, this is pretty helpful. And my personal favorite, because I think it's probably the most action or strategy oriented. Okay, so the next part, jumping into the digital circular construction side. So how can we use different tools to upscale some practices in the context of construction? And a lot of this is based on the work I was working on in my previous lab at ETH Zurich. There's a lot of members out there looking at different sorts of technologies. So I'll synthesize some of the approaches here. And so what is this exactly and why is it important? Well, if we think about our existing building stock, so our material supply, what we have in circulation already, then our material demand, where are we building new? We need to figure out how to connect these from a physical and logistical perspective. Now, for circular economy, for things such as textiles, when you want to reuse a shirt, for instance, perhaps if the tag is pulled off the back and you don't know exactly what the material is made of, it's okay. You can still wear the shirt as long as it fits. This becomes a bit more challenging when we think of the construction industry, because if we want to reuse a steel beam, but we don't exactly know what the strength of that steel was, there's a whole lot of liability, and you're not going to find a structural engineer who's willing to stamp these drawings. And so what's equally important with the material is the information on these materials themselves. And so we're looking at how can we use different strategies and tools to combine, to collect, to combine, and communicate the information with these materials. And so the framework proposed that has this D5 framework, which includes the disassembly, distribution, design, deployment, and detection. And each of these can be facilitated with different sorts of technologies. And so I'll dive into each of these steps and give an example for each of them. First, it would be on the detection side. So, as mentioned, there we have this existing building stock, but another issue faced in our industry is due to the longevity of construction. We oftentimes lose the initial design drawings or as-built or the information on these buildings, especially the older they get. So it can be used tools, in this case, computer vision, to automatically detect this information. So we can classify on the far left that this is a brick building. Then we can detect where are the windows and how many are there. And then from there, we can segment into the type of material component. So there's X volume of bricks on the facade, Y volume of glass on the facade. And we get this high-level material overview of these buildings. And this can be helpful at an individual level, perhaps before demolition or deconstruction, to get an understanding, do an audit of these structures, right? So similar approaches can be used inside, but it can also be used at an urban level. So if we use Google Street View images, for instance, we can en masse collect a lot of urban information about what typology or what the facades are made of in a certain city. From detection, moving into the disassembly side. So this is very much an active area of research and far from commercialization, but can we think about how we might be able to automate the disassembly of a building? And so this particular researcher has developed a workflow. We start with scanning a certain component, segment, in this case, a steel element, segmenting it. Okay, so where's the steel? And then can we detect where the weld beads are, where the bolt holes or the physical bolts are themselves? And after this, we can use a robotic arm to automate the plasma cutting right along the seam so we know where the edges of the beam are. And then from this, we can extract the beam itself. So a bit more the hardware focused, but it is, in theory, it is possible. And I think an important tool to add to our arsenal in digital circular construction. On the distribution side, so I was talking about textiles earlier, right, or shirts, or so a lot of these products, similar to grocery stores, consumer goods, have barcodes, and these barcodes, there are apps that you can read this product information, perhaps where they came from, where the textiles are from, the brand, so that you see this at the consumer level, the cashier, the distributor, and so we have this provenance of information through the life cycle of material. And so in the distribution side, how can we apply these principles to our construction materials, particularly our valuable ones? So using technologies like QR codes or RFID chips, and even there's some futuristic research on even using DNA as information storage. Can we keep that information available through the life cycle of a building, deconstruction, and reuse in a different application? So this lends itself to concepts sometimes called material passports or product passports, which is this suite of information associated with the particular construction product. On the design side, so this particular research paper was looking at if we have a known finite set of elements deconstructed previously. So we have a wood frame with a certain amount of linear elements, and we have the dimension of these elements. Can we create a design algorithm to automatically match it to a new structure based off the given constraints? One of the challenging parts of circularity in construction or reusing in construction is that when we're doing a new build, we can pick the dimensions that we want and just procure them from the factory. But when we're reusing, we are oftentimes constrained by what is in our existing material stock. So this adds another layer of difficulty that we can perhaps help automate. And then lastly, on the deployment side, so using tools like augmented reality and virtual reality, can we facilitate the reconstruction or construction of materials by having placement instructions or disassembly instructions or having product information appear as people are actively in the construction phase? So this was an overview of different technologies and tools that we can use to digitalize the different processes of circular construction for this D5 workflow here. And then I'll move a bit more into the material side. So it's circular construction materials, particularly on concrete. So we have this broader issue of industrial solid waste. And so there's industrial solid waste and municipal solid waste. So the municipal waste is the waste that we throw out in our trash cans at home. And we kind of have an idea of how much waste we produce, how much we have to take out the trash, right? Industrial solid waste is difficult for the average consumer because it's not something we really see or interact with because it's happening on the industrial side. So this is coming from the manufacturing, the factories, the mining, also from construction and demolition. And there's a lot of it produced. Particularly in the US, the numbers average out about to 20 tons of industrial solid waste is produced per person per year. And so this is to produce things like the roads that we're using and all the materials that we're using. And there's a phrase which more or less goes along the lines of if you can't grow it, you have to mine it, right? So every material in the building that isn't from an organic base had to be mined at some point. And so this is a really big industry which produces a lot of waste necessarily. So how do we deal with this waste? In comes concrete, everyone's favorite material. It gets a lot of rap from some of the folks who are working on the organic side because it is very energy intensive process, particularly in the cement, which is the most important ingredient. Cement acts as the glue between the rest of the materials, which include water, sand, and aggregate. And so when people talk about the CO2 footprint, it comes down largely to the cement manufacturing, the cement production. And so the water and sand and aggregate are the more natural ingredients around this. And what's also important to recognize, though, is that concrete is the second most used material in the world after water. So even if we can replace some concrete with some perhaps organic-based materials or nature-based materials, concrete is still it's not going anywhere. It is vital for our infrastructures, for our foundations, for a lot of the construction we have going on. So what folks have been looking in already, this is not necessarily a new idea. You can find traces of supplementary cementitious materials all the way back to the Romans. But it's this idea of and if we have a set volume of cement, can we reduce that and replace it with separate materials, including some of this industrial solid waste, right? This slag or this fly ash, and achieve similar properties, or perhaps slightly vary the properties as needed. So some of the work that's come out of our lab is the use of a natural pozzolan, which is a kind of a volcanic rock in origin. In this case, these were originated in Chile as a supplementary cementitious material. And so with this, we ran different tests with the NP0, so with a 0% replacement, or the business as usual case, compared to different amounts of replacement with the natural pozzolan, with this industrial solid waste. To achieve similar or slightly varying properties for our concrete. So this is word valorization really kind of means or lends itself to using of waste or the reclaiming the value out of the waste, out of the industrial solid waste. So as I mentioned, concrete is important for our infrastructure. And the US, we have this wonderful organization, the American Society of Civil Engineers, which provides a grade for all classifications of American infrastructure about every 3 years. And this year, I'm not so happy to report that we received a very solid C in our GPA, which is passing, mom and dad. Keep that in mind. But you can see that there are different types of infrastructure that are a bit behind, such as levees and roads, and different types are doing well. So why? What are the challenges for infrastructure? A lot of it has to do with concrete, to be honest. So the decay of concrete. Or I'm sure we can all think of stories of a bridge collapse, for instance, where we needed more tailored maintenance or more frequent maintenance or repairs of these infrastructures. So the challenges associated with concrete at a high level, it's a very brittle material. It's good at taking compression in this direction, but it's bad at tension and this bending force. And so that's why we oftentimes put steel rebar inside the material. It's concrete is prone to cracking, and then with cracking, water with chlorides can come in and cause that steel to rust on the far right, and this will can also cause failure or spalling of concrete. So how do we deal? How could we deal with this? We could move from a large crack to a smaller crack, and from a brittle to a more ductile or bendable material. And so this is another research stream that we're interested in this lab is adding a different type of additive through fibers into this cementitious composite or this concrete that allows for more smaller cracks, so it's not so large of a failure and increases the compressive strength as well as the bendability of this concrete, which lends itself to, as I put in the top left here, this repairing strategy, right? So if we don't have one of these R strategies I mentioned in the beginning, if we don't have as much concrete that decays over time, then this helps with the repairing process. So overall, when we combine these two strategies for concrete, so we have the industrial waste valorization as well with the bendability. How does this lead to circularity of concrete? It does so through the repair strategies, the reduce and the recycle. So when we're talking about reduce here, we think of the whole life cycle of an infrastructure asset. Perhaps a bridge needs to be repaired every 10 years. And so we have to, or even now on campus, on MSU's campus, a lot of these roads are being repaired, right? So there's a lot of traffic. And so we have to tear up this top layer and then pour new materials every so many years. If we can make these materials last longer, twice as long, then that cuts the total amount of material in half. And then lastly, for recycling, right? So bringing in this industrial waste into the cementitious materials itself. Okay, so to bring us back to the last chapter here, future thinking. So what is the current status of circular construction? What can we be thinking about and across the United States? And so personally, I come back to this model a lot, which was put forward in this paper at the bottom, Circular Futures. Not necessarily to do with construction, but I find it a helpful model for thinking about what the future might hold. So it's these two axes, right? So this one axis on centralized versus decentralized governance, and this other axis of low technology versus high technology innovation. And so a centralized high tech, this sort of circular modernism, we can think about planning a new city from scratch, right? So from the beginning, it's already going to be circulator materials, our energy, our waste flows. Also, from a centralized governance perspective, we can look to the Netherlands, for instance, who is trying to be net zero waste by 2050, a whole country, which is very difficult considering about a third of their waste is from construction and demolition. But this is a sort of top-down mandate that is causing a lot of disruption and innovation at the bottom level. Or on the decentralized focus or in the low-tech innovation, I had a colleague who was looking at informal circular economies. So if we look largely at the global south, she worked with some waste pickers in Bangalore, India, who go to demolition sites and manually pick out the high-value materials here, and then are able to resell them to contractors on secondhand shops. So there are different approaches to what circularity can look like, as well as in how much technology can or should be adopted. Some policies in the US I'd like to highlight just to for a bit of optimism here at the federal level. So who is the largest real estate manager in the United States? It's the federal government. So they've a lot of property rights, or a lot of construction going on. And so with this Buy Clean initiative, it prioritizes the procurement of local low carbon materials for federal projects, as well as putting a tax on demolition waste. So disincentivizing the production of waste from our buildings. So we can do that through diverting through recycling streams or just demolishing, deconstructing less. At the city level, there are various cities that have implemented deconstruction ordinances. So Portland, Palo Alto, San Antonio, Milwaukee have these ordinances where you're required to deconstruct as opposed to demolish buildings. So again, it's if it's coming from a policy initiative, it's causing companies and owners to think differently about how they manage the life cycle of their assets. And then San Antonio also particularly has a vacancy ordinance. And then I am reminded by Dr. Lamore's work on dome ecology and his past presentation on some of the issues in this area of the U.S. But so we have these vacancy issues. So San Antonio has this policy in place where you can register as a vacant building, and they have some programs in place that can help bring in funding to kind of revamp some of these buildings so they aren't sitting there decaying in the community. And then a bit at the state level, so I'll particularly highlight California and New York, where California's building code, Cal Green, I know some folks that are actively trying to implement some circular practices in their building code there. And in New York City at first released these circular design and construction guidelines. And it's been scaled up a bit into a white paper for state recommendations in collaboration with some researchers out at Cornell. And so here, providing guidelines for sustainable material use and waste reduction. And they're hoping to, as they get some more case studies, they can build more information to provide more tailored recommendations. So what could it look like? I'll highlight three different companies or projects going on that will be interesting to continue to follow. The first in California is a company called Urban Machine. So they are a unique startup out there that are very tech forward in their approach, where they have this mobile, solar powered, robot guided assembly line that uses computer vision, and all of the fun words, and the really cool project out there where basically if you have this timber coming off of a construction or demolition site, perhaps it's formwork or it's old timbers from framing. If you could drop it on this assembly line, it'll use computer vision to identify the extra screws or metal fasteners, and a robot arm will help pick these out. They're sanded and refined, and at the end of the line, you can potentially reuse this wood again after the visual grading. So pretty cool, this mobile application to keep these timbers in use for longer, right? This the core of a circular economy. This company, Circo Trade, is actually based in France, but are trying to increase their global footprint. And they are interested on the economy side of a circular economy. And so what are they doing? They're building a platform for futures, market platform for the steel building elements. So can we create financial incentives to think more long term for our buildings? So if you are a building owner and you know you're going to deconstruct your building in 10 years from now, can you sell futures on your steel element? So effectively, other people will become owners of these materials when they become available, or treated like a commodity trading. But the commodities are actually over your head right now. So a pretty interesting idea that they're getting off the ground. But a lot of the challenges in circular economy and construction are financial, as there's generally a low profit industry. And then lastly, the most ambitious project that perhaps you've heard of in the news is NEOM out in the Middle East. And one of their projects is called Oxagon, which is a floating industrial center where they want to use a lot of Industry 4.0 technologies and circular economy principles to create this future of a sustainable city. And so some of this will come through 100% renewables from the energy side, and then and a bit on the material side as well. But it's interesting that the ambition is there, and we'll see as the construction continues how that unravels, or what the success rate is. So To wrap things up, what I talk about today? So I began with the different circular economy models, so different conceptualizations through time, and some of the big ones to keep on the front of mind. Ending with the 10R strategies. Digital circular construction, so touch on a couple different technologies and tools that we can use to potentially facilitate or upscale circular practices, and the overall framework we can use to think about digital circular construction. Then touched on circular construction materials, particularly concrete in this case, so the circularity potential of concrete, and the work that we're doing here at Rise Lab. And lastly, future thinking. So what could the future of circularity and the built environment look like from both the policy level, from top down and bottom up, and high tech and low tech? I think there's a lot of potential for this industry. So yeah, that's all I have for you today. Feel free to reach out to me, and as well as thank you for hosting me here for this talk. And very excited to field some questions, and hopefully we can generate some ideas for collaborations between Rise Lab and the great work happening here at MSU. Thank you all.
Awesome. Thank you so much. If anyone has any questions, we could do some Q&A.
Yep. So some question in the chat from Dr. Lamore. So thoughts on short and long-term policies that might help us move in that direction. Yes, that's a great direction or a great question, and obviously a great direction as well. Um, yeah, I mean, moving into the policy recommendation side is a bit difficult, and I think that's a part of the value of this network here, right? Is we need more interfacing with the people who are on the ground doing the work. Um, I think there is this balance between this top down and bottom up. I mean, and from my past work in Europe, there's a lot more policies that do come from the top down. And I don't think that in the US ecosystem that works as well. There's a lot more innovation on the ground here, in my opinion. And so, but how do we create these incentives to begin with? And so it's always going to be a delicate balance, I think, between or this, at least in my opinion, the deconstruction tax or the landfilling tax, I think, is interesting. So if we just at the end we create a disincentive for producing waste, then I think that will generate innovation at the user level of how do we keep our materials in use for longer. So this is sort of adaptive reuse of our structures as well. I think is a big part of this, but not necessarily a little bit of the carrot or the stick. Yeah, construction is a low margin industry, so we don't have so much to play with here. But I think there are creative ways to get there. Yeah, great question. I think another challenge in this industry is that there are so many different players, right? So if we're talking about from the general contractor side versus the architect, and from my perspective, a lot of this drive and interest in circular economy is coming from the architects themselves. Um, um, and so they're coming in with a bit more passion. And so I mentioned in the beginning, Arup has teamed up with Ellen MacArthur. So I would point to a lot of resources produced by Arup. I think it's mainly coming out of their London offices, to be honest, and but are more universally applicable as well. Um, yeah, I think in from the bottom up, there's a lot of local deconstruction subcontractors, and so I can't give you any names based off of where people are calling in from, but the I would look at the hyper local level, right? So oftentimes these are kind of bespoke, just a few person teams that have been in the community around longer, and have done this for a while. And so I think these subs tend to get a little overlooked. They're yeah. So at the smaller level, and then at the bigger level, a lot of the architects are kind of pushing this as well. Yeah, and then one question came in: who is financing these initiatives, investment funds for sustainable infrastructure in the United States? Um, Yeah, also great question, right? The financing is the big challenge. I mean, I briefly mentioned the Buy Clean initiative for the federal construction, and I believe that's a bit more for the building side, though. Moving into the sustainable infrastructure, I think that there are different mechanisms. Infrastructure also has its own unique flavor because they're a bit more public-private in cooperation, right? So not just a kind of a private real estate owner. Um, I think there are. I'm not sure I'll be able to give a satisfactory answer, to be honest. I think there are people who are encouraging this. We're looking into this, but I don't think there is a an explicit fund that I can point out. I could just say that I know of different states that are working on trying to implement this. But yeah, federal infrastructure in the U.S. outside of the Buy Clean initiative, I don't think it's there yet. Recent state policies regarding bonding to support deconstruction of energy infrastructure. Any thoughts on that? Yeah, I believe I remember you talking about that in the past, Dr. Lamore. So that, yeah, I mean, yeah, I'm not the expert here. I mean, I'd recommend for those who haven't to check out the Dr. Lamore's past lecture on that where he talks about this. I mean, I do think it's important, and I mean, so Circo Trade was the one company based in Paris that I mentioned, and so I do believe that is going to be critical for unlocking the financials of these bigger projects. Is we need to think about what financial mechanisms can we bring in that have these long-term perspectives. So bonding, yeah, was I think one way to do it. A futures market, which is a bit more kind of a public trading. This is where we would like to rope in the economists out there, or the folks that bring in that perspective, not just the construction perspective. I mean, the economies have a circular economy. So I am cautiously optimistic about it. I do think it's worth exploring further, and hopefully we can see some more positive projects on that. This is one of the challenges with renewable energy, at least, is if we think of solar panels and wind turbines, is that they have relatively shorter life cycles, 10, 20 years. And so I know of some researchers already who are looking at how do we start to reclaim these assets at the end, or what materials are still valuable. Because the sad truth is a lot of wind turbines at the end of the use are just buried in the ground and they're a bunch of polymers. If you have to pay for deconstruction, do you think that will incentivize new design practices and reusable materials? Um, yeah, I think so. If you have to pay for deconstruction, yeah. And so I think this is the word is the cost born, right? This also has to do with the concept of dumb ecology. Are we bringing the end of life costs, both like financial but also environmental or social costs up front to the person who is the owner, or the person who's initiating the construction itself? Can we somehow bundle that future costs into the present? I mean, I do personally believe that. I mean, there's some terms thrown around design for disassembly, or design for reuse, or design for adaptability, which, yeah, I see a lot of movement in from the architects, but also the folks in the industrialized construction sector. Um, but I think that the more we can anticipate future demands, or anticipate the flexibility or the unknown of future demands, the better we can equip up the future generation. Um, so yeah, I mean, some of this comes back to in the beginning. I talked about the cradle to cradle, these different nutrient cycles, right? So if we think about like what materials are going to be easy to deconstruct or recycle or reuse up front, then that's pretty important. On the other hand, looking at materials or structures that have been around that can exist for long periods of time without necessary maintenance, right? And this is I mean, a classic example, though of course it's not used in the same capacity, but is the Parthenon out in Athens, been in use for 2,000 years, right? And it's still standing. And I think that's a bit difficult for us to comprehend in modern American context, where we have a lot of homes that are around just for a couple decades before being replaced. So yeah, thinking how do we really wrap our heads around the time dimension of our built environment?
And yeah, thank you. Have
Thanks for having me. Have a good Thursday, everyone.
a good one.